welcome to our afternoon session. Basically, what I'm trying to address is a lot of sub-modules are discussed on platforms like this. But who's going to tell us how do we plan electrification zero up for a building? Suppose if you are given a structure by an architect or a developer, how do you put pen to the paper? What is the first thing which you do? And what are the things which which are expected from you as a designer? So first thing, I would like to explain that when I say large building, in fact, it will be applicable to tall buildings also. Large could be when the same large plate size in the horizontal plane. Now both of them will have the same parameters to address. And today, what I'm going to address is basically on what are the tools available to designers with new technologies, number one. Number two, new materials. Material sciences has taken a big jump. The switchgear sizes are going small, not because of electrical technology. They are getting more compact only because materials are better now. Insulation materials are much better. And lastly, regulation. See, government regulation dictates how you design the system and what you are permitted to do and what you are not permitted to do. Now, to avoid any controversy about regulations in Maharashtra or Delhi or something, what I have done is, because we are going to talk about tall buildings, mostly my submission would be for a particular city, which is New York City. Now, what are the regulations there? As you know, 75% of the tall buildings in the world were located in that city. Now, of course, with Asia and Far East growing at a faster pace, now only 25% of the tall buildings in the world are in New York City, but still it is a trend setter. Now, definition of the tall building varies from place to place. High-rise committee, government bodies, municipal corporation, they have their own numbers. But basically we know what are we talking about. So tall buildings is more of a generic term. Now consider this, that basically the key word is superscaling tall buildings at the bottom in New York City. Now here the real estate is so expensive that they keep on going up, and only one apartment to a floor which may cost millions of dollars. See, Saudi Arabia is constructing a building which is 1 kilometer tall. It is not in terms of meters only. 990 meter is the finished height of a building in Saudi Arabia. Now, suppose if you have a 1 kilometer distance on the horizontal plane, naturally you will have a lot of issues addressing the electrification design. Now you raise it up, the issues are the same. Electricity has no aversion to gravity, but the principles are the same. So if you have a 1 kilometer height tower going up, do you think that our current method of electrifying what we call tall buildings, will they hold good? May not be. Now that is where we are going to address certain issues today. See, common sense is one of the immediate concern would be remote tariff metering. Who's going to, access meter at say 500 meters height? How do you do that? So remote metering will not be a luxury, it will be a necessity. Also, fire assumes a very, very dangerous situation for people living at that height. It is not possible to save them, and personal safety becomes paramount. So LSS means life saving system. They are very, very crucial. See, this variation in the direction of the shaft while dropping down from top is important because venturi effect would bring down the air to the ground floor lobby at such velocity that it may break the glass of the main door. Though you got to change the shaft direction to kill the venturi effect. So these are unique to the very, very high-rise buildings. See, service core will always take care of the utilities. There is no denying that fact. It says that you have elevator shafts, electrical, everything in the core, and that core could be concrete. I mean, pre-stressed concrete core is created, and then you have deliverables on the plates around it. See, this is a typical high-rise in the Billionaires Row. This is not downtown Manhattan. This is further up. This is a cheaper land, but even that is not available. So consider this: 1:24 is a width to height ratio. 1:24. It is unthinkable. I mean, that is how they are. So they are troubled by wind resistance. So how do they attend to that? They keep 2 floors empty every 12th floor onward. See, every 12 floors there is an interval of 2 floors, no occupancy. At the most you can have some utility equipment, but they want the air to blow through that and reduce the stress on the structure. Now, another idea is to go high up so that they can sell the property. If the view is better, you can sell it at a higher price. And what they do is that they buy the air right from adjoining building. Because in this zone, suppose you are allowed to go this high, but the old building is only this building can sell the air right to the new project. Now, this is the heart of today's submission. That how do we ultimately start planning the system? So basically 3 steps are there. They are more like categories, not steps. The first is how do we service the needs of the building? So first service means how do we service the need of the building? And ultimately, everybody is creating a structure for using it for some function or the other, residential, commercial, educational, whatever it is. So you need to understand what is the need of the building. Now, the need will decide the utilities. Then, of course, we have protection. So, what is very important is that we cannot ignore smart switchgear anymore. See, smart switchgear will take out all the hard wiring out of our systems. It will be possible to configure star delta starters, dual starters, any switchgear configuration through your laptop, and the digital unit would be identical, and it gives you huge flexibility for interlocks, for configurations, and even tripping curves can be adjusted on an ongoing basis. See, fire, how do we take care of fire? The hazard as such. Of course, the insulation materials, whether it is halogen free, smoke free, that is one aspect. And of course, we just saw in this place itself, there is an exhibitor who will tell you how to seal the spaces in the shaft interfloor, how not to permit fire to go from one floor to another floor. Every orifice, every cutout should be sealed with a fire rated material. See, fire has heat as well as toxic gases, what we call smoke. Smoke takes more lives than heat itself. Now, lightning strike is a natural phenomena for very tall buildings. They attract strokes very easily, and factory engineered system has to be opted for. Now we will take up one by one. The service part is the first thing to be considered in the service are the sources. See, in this drawing tells you basically the restart time. See, the grid power, once it trips, you need at least 60 seconds to set it right again. Backup generator on AMF will need minimum 12 seconds to build up voltage on the terminal. UPS requires less than half a cycle. So it is the quickest one. So that will decide what feeds what. Because the cost is also going up from grid to DG to UPS in the same direction. So you cannot use UPS for any and every load. You can see the transformers are with OLTC and generator is with AMF and synchronization panel. An advantage of UPS batteries feeding the load is not only the speed at which it corrects the situation, but also it gives you clean power. This is the key word, clean power. Now, what I mean by clean power is there are no harmonics, there are no surges, and it is pure sinusoidal waveform. There are no distortion. So you don't have to worry about harmonics. See, gas insulated HT panels and compact substations are basically to reduce the footprint size of the equipment. DG multi-fuel, this is important. Diesel is not going to be easily available in future. So we will depend on other fossil gases like CNG, PNG, LPG, propane also. Propane is a very good option. Only catch is it is not conducive for engines, and it has a lot of knocking and vibration. But Caterpillar is able to give you 1 megawatt engines using propane. We have used it successfully. Gas turbines what we saw here. I've lost it. Okay, we will jump to this. See, gas turbines are a very good option for directly coupled load. If you have a load, especially chillers, you can directly connect it to a gas turbine. And turbines don't need shutdown for years together. See, a turbine is same as an aero engine. So if you have a aircraft coming from New York, 18 hours non-stop, it will stop at Mumbai airport, and it will not switch off the engine, because if there is a 2-hour stopover, the engine is kept running. It is very easy to keep it running rather than shut down and restart again. So turbines cannot be operated like DG sets, but they are very good for base load. Now coming to statutory requirements, you please understand local laws, various bodies, MOEF, CPCB, and all are applicable to HT consumers. You are all familiar with that. What I wanted to emphasize was the accident. So if there is a fatality accident, it's a very serious situation, because labor officer as well as police comes into picture, and directly the owner of the establishment is under the crossfire. It cannot be ignored. There is no escape. It has to be attended to. Now, yeah. See, lightning protection, basically Faraday cage, and there are manufacturers who give you factory built systems like OBO and even DEN also, and they will also guide you what should be the ring around the building, horizontal. See, these buildings need aviation lights on top as well as on the sides also. Similarly, lightning protection ring along the building is required. This is another way of how to design it. See, mesh method means Faraday one, rolling sphere, and of course the protective angle, which will work very fine for many things. And these are the components of the lightning arrestor. See, please, this is very unique that your RCC angular structure can be used as a down conductor. You don't have to lay a down conductor separately. While casting, if you have a bonding done on an ongoing basis, you can use it for bringing it down to ground. This is very important. See, IEC 62561 tells you how to install a counter. See, there is no way you can make out whether your lightning protection system is working. You need to have a counter. Then only you will be able to ensure that it has done its job. Otherwise, you will have lot of strikes going in here and there, but you will not know whether we have been protected. See, this is inductive and galvanic coupling. Suppose a strike, not many people are aware of this. If a strike occurs in the vicinity of your house, in a lawn or in a garden somewhere, you will still have surges coming into your house. See, in USA, Midwest, which is a fertile ground for lightning strokes and all weather situations, even a child knows that you should not use a telephone line during storms because it will have a flashover. This is the stroke on a overhead line, and then the surge comes into the house. Now, what are the surges and what are the criteria for surges? One thing, please believe me, any and every planner will have to bring surge protection devices into your scheme of things. What ELCB was 10 years ago, now you will have a surge protection as we go forward. You cannot avoid surge because it kills your electronics and the damage could be a couple of lakhs of rupees in a house. So what do you do is that you have three categories, type 1, 2 and 3. How they are typed? They are typed by the way the wave is coming into your establishment. And how, depending on the wavefront, you have to quickly get rid of it. And these categories are defined by that. This is a flow chart on the selection of the now lighting. Earlier, all of us used to, even electrical engineer used to take care of lighting for high rise. Now it's time that we should have specialists who will work with electrical engineer, structural engineer and mechanical engineer in close coordination, because they have a very different set of requirements. High rise buildings. Changing the lamp itself is a challenge. Aircraft warning lights, we just realized that you need warning lights on the sides also. Architects resist that because it defaces their profile, but then it is a requirement. This is, remember I told you right in the beginning, life-saving systems will assume more importance for high-rise buildings. So this is part of the same thing. Okay, thanks a lot. I'm grateful to you for your time. Any questions if you have, you can ask me. Thank you.